Welcome to a lesson with Dr. Powell. Let's take a look at how imaginary numbers, complex numbers, are really just two-dimensional numbers. How does that work? Well, let's first take a look at the number line, one-dimensional number line with real numbers on it. 0 in the middle. You have numbers to the right, positive numbers, numbers to the left, negative numbers. And in particular, any positive number, say like 2, you can think from 0, we're going in this direction, so we can think of it as being an arrow. So the number 2 is really just an arrow going this with a length and a direction. Direction to, because it's positive, so the positive direction. Okay, so if we think about maybe like -1, right? -1 is a number, and its arrow starts at 0, so the tail of every number is at 0, and then it's going this way, just that much, and it's facing that direction. So the numbers on the number line are really just arrows, right? So how would you add two things together, like two numbers together, using arrows? How do arrows help us with that? And we're going to relate this to complex numbers and imaginary. All right, so first of all, let's just make sure we got this. So -1, all right, let's take that and let's add 2 to it. How's that going to work? Well, if we simply take this arrow right here, we lift it up, we put it right there, okay? What we're going to be looking at is we're going to be looking at where we start to where we finish. We start and we went back and then here, but we're only interested in the first tail and the last tip. So we take the first number, -1, and we add 2 to it by picking up 2 up and lifting it, so the tail of it is at the tip of the -1 arrow. So we have the -1 arrow right here. This is the -1 arrow. This is the +2 arrow. And put it together, it takes us somewhere from there to there. We end up getting a resultant arrow from the beginning tail to the ending tip. Now on the number line, this looks like from here to here, which is +1. All right, so we add, basically, we're just illustrating that the numbers on the number line are like arrows. And when you add them together, when you add them together, it's like you're doing arrow math. All right. Okay, so that's real numbers. Now let's talk about, that's one-dimensional. Let's talk about if we want to have something that's two-dimensional now. Let's beef it up a little bit here. So let's see. Let's suppose that we have, our real number line. It's one-dimensional. And let's suppose we just say that we have a number. Numbers are just arrows, and they go on this line back and forth. So why not just have an arrow that points directly upward? Just call it I. Makes sense because, I mean, is our world only one-dimensional? If it is, then we only think that arrows can be to the right and the left. But it's not. We can see more than that. We can see that arrows work perfectly fine if we point them upwards. And so arrows going up are just as real as numbers that go to the right or left, only it's a misnomer. We don't call them real, we call them imaginary. That makes everyone confused and think that they're just some abstract funny thing. But really, they're as real as can be. Again, I would say it's a misnomer. So it's just, think of it as an arrow that points upward. All right. So then if you have an arrow that points upward and you have, let's see, and let's say you have an arrow that goes this way. Suppose you have the number 2 and I. And let's consider how they add together. I plus 2. It's just arrow math. What you would do is you would pick up this arrow for I, but I'm not going to necessarily pick it up right now, but just imagine I've picked it up and I've placed it right here, a copy of it, but it should look the same. It should have the same length. But and then what I do is I go from beginning tail, which is at the origin or at 0, and I go to the ending tip, and I end up getting, so that should be the sum of the two. All right, I'm going to think of that sum as being I plus 2. Now, coordinate-wise, you can think if this is an x-axis, and right here, let's just imagine that we have a y-axis here, then really coordinate-wise, this is, you think of I as being 1 unit up, say, if we were to say I was 1 unit long, then this point right here at the tip of this new arrow that we have for I plus 2 is really just at the point 2 comma 1. In fact, we could have rewritten I plus 2. In fact, let's do that. Let's rewrite it as 2 plus I, just so it looks like it has the same ordering as that ordered pair. Okay, so 2 plus I. All right. In fact, this is what you'd call a complex number, where I itself you call an imaginary number, 2 is a real number, and you say that the imaginary part of this complex number is the coefficient of I, which in this case is 1 times I, and then the real part is just the real number right there. So the 1 is called the imaginary part. The 2 right here is called the real part. So you have a real part, imaginary part for this complex number 2 plus I. Great. Okay, so let's look at another example here. Briefly, all right, let's see. Let's suppose that instead of just dealing with I, we dealt with maybe like 3i. So what's 3i? Hey, 3i is I plus I plus I. So if you want to stick to just adding, think of an I, then another copy of I, and then another copy of I. You're going to be right there. You can call an arrow that goes up like that. I'll just draw it to the side so you can see it. You can call that arrow a 3i arrow. So what would 3i plus 2 be? Or 2 plus 3i rather? You'd think, okay, so 2, and then you put a copy of 3i right here, and then the resulting from tail to tip. And I'll erase that I so we can see this a little better. Let's see. Draw that again. All right, that arrow is going to be 2 plus 3i. Okay, that's the 2 plus 3i arrow. And you could think, and this point, of course, in coordinates, would be 2 comma 3, 3 on the y-axis. So every single number in the plane here can be represented by a complex number, like 2 plus 3i or something, where we're thinking of everything as arrows. Now, this is really nice, actually, when we think about multiplication. So, and that's in another video I have, the next video in the playlist. So, here it is, complex numbers. Go to the next video to see why this might be a nice, useful thing to have for the points on a plane to not only be described as ordered pairs, but as funny complex numbers. It happens in the multiplication. Go to the next video to see why. Thanks for watching.